Ladies and gentlemen, the lecture is about to begin. Please be seated. Ladies and gentlemen, we are delighted to have you all with us today. I am Angel Wu, a Year 2 student from the Faculty of Engineering. This inaugural lecture celebrates the 100th anniversary of the Taikoo Professorship of Engineering. We're extremely honored to have with us today Mr. Merlin Swire, Chairman of John Swire & Sons Hong Kong Limited. May we invite Professor Richard Wong, Acting President and Vice Chancellor, to deliver the welcoming remarks. Professor Wong, please.
Good afternoon, Mr. Swire, Laura, ladies and gentlemen, distinguished guests. Thank you all for coming to Hong Kong University. We are here at the Rayson Huang Theatre, and we are celebrating a significant event in the history of the university. And I hope also a significant event in the history of Swire. It is not usual that a town and gown has been able to forge such enduring relationship over a century. Particularly in engineering, but beyond engineering. Engineering is one of our 3 founding faculties at the university. It has made an important contribution to the development of Hong Kong. And Swire, as we all know, is literally everywhere you can see on Hong Kong Island at the very least. And of course, you cannot leave Hong Kong or arrive in Hong Kong without taking Cathay Pacific. Well, maybe the lady Maureen for the governor, but for most of us, more humbler origins, Cathay is a good answer. I think the most significant event is you walk around the campus, you see so many contributions that Swire has made to the university. If you start next to the President's Lodge, you have the Robert Black College. And as you come down, descend, you see students live in Swire Hall. And if you were to take an occasional outing to the Swire Marine Lab, where Hong Kong's telephone mobile system cannot reach, you still see Swire name emblazoned on the Marine Science Laboratory. And of course, the Taikoo chair, which is now the Taikoo Professor of Engineering, is a symbol of great endurance. And it is a great pleasure that I am able to represent the university to show Swire that we are really proud of the association. And of course, one last word. I now, since April 1st, I found that my offices is now located again in the Knowles building. So day in and day out, I live under the shadow of Swire. And I cannot forget that. And I remind all my colleagues that the partnership that one of the oldest companies in this territory and the oldest university in this territory is forged on the belief that we will make Hong Kong a better place, have a better future. And today, the footprint of Hong Kong is extending beyond our boundary, our waters, to embrace a larger Asia. And where Cathay flies, we hope we will be there too. Thank you very much. And I'm glad that we have this celebration. Thank you.
Thank you, Professor Wong. Please be seated. Could we now invite Mr. Merlin Swire, Chairman of John Swire & Sons Hong Kong Limited, on stage to address the occasion. Mr. Swire, please.
Well, good afternoon, everybody. Professor Wong, thank you for those very warm words of welcome and a wonderful plug for Cathay Pacific Airways. I wish it was the only choice of airline in and out of Hong Kong, but we haven't quite got to that point yet. I wanted to say really first and foremost just to say how proud we are to have had this very long association with Hong Kong U. The brief slideshow you put together for me was a very moving example of that across many decades. It was very moving for me to see my uncle and my father up there at different Hong Kong U events. And you know, we feel particularly proud, I think, to have been here since the very start of the university as a major donor at the outset. You know, it's a world-class university, and our involvement has particularly been on the engineering side, and I think the engineering faculty has contributed to Hong Kong's reputation as a really leading centre for engineering skill. And I think that early donation we made at the start of the university was I hope, largely altruistic and based on a belief that, you know, a high-quality university and good education in Hong Kong was going to be a valuable thing. But it was also, to an extent, self-interested. And as the title of Professor Chien's lecture suggests, the dockyard business was something we were in at that point. And 1911 was when the university was founded, but we started our dockyard in Quarry Bay in 1907, and at that stage it was the most modern and advanced dockyard in Asia, I think, and it was first of all repairing ships, and then in 1910 it actually built its first steamship from scratch and delivered it, first of very many ships. But at that stage, the engineers working there were almost exclusively from Glasgow in Scotland, which is a very long way to go to source engineers. And I think we felt that finding some engineering talent closer to home would be a good idea. So our association with engineering is kind of based on that original premise, and as a result, I think the relationship for us has been very much a two-way thing, and we've derived tremendous benefit from the quality of engineering that the engineering faculty has produced over the years. We certainly did during our dockyard days, which were 60 or 70 years of operation in Quarry Bay. But even today, we employ a lot of engineers in our airline business, in our aircraft maintenance business, and in our property business. And I would implore all of the undergraduates who I see in the audience today who are studying engineering to consider the Swire Group as a possible source of employment in future. And we certainly continue to have a need. So, for us, the relationship is really important. It's really meaningful. We feel it's a key part of the way over time we have remained engaged and connected in Hong Kong. And it's great to be here to hear Professor Chen's inaugural lecture on the 100th anniversary of the chair. I think when we first met, we met briefly, we talked about this, and at that stage you were talking about 3D printing, and you've set yourself a much harder task now, which is in 45 minutes to talk about from the dockyard in 1911 to artificial intelligence today. So I think we're all very excited to hear what you're going to have to say, and I'll hand over to you at this point. But thank you all, and Professor Wong, thank you so much for this welcome.
Thank you, Mr. Swire. Please stay on stage. Could we now invite Professor Wong to present a souvenir to Mr. Swire? They will be joined by the Dean of Engineering, Professor Christopher Chow, and Taikoo Professor Norman Tien. Thank you all. Professor Chow and Professor Tien, please remain on stage. The Dean of Engineering will now introduce the speaker.
Good afternoon, Mr. Swire and Mrs. Swire, ladies and gentlemen, distinguished guests. It is my greatest honor to be here to introduce the speaker, Professor Norman Tien, today. Many of you may not know that I'm actually a former employee of the Swire Group. Some 31 years ago, at that time, I got my degree from University of Hong Kong. My first full-time job was with John Swire and Sons. So I spent a few years working for Swire before I moved to the US for my graduate study. So that might be another reason that I was chosen to introduce the Taikoo Professor of Engineering today. So, well, Norman is a well-known expert in microsystem engineering. He is my predecessor, serving as Dean of Engineering until last year. He built a very strong foundation for the Faculty of Engineering, and this makes my life a lot easier. During his term, the undergraduate curriculum structure of the Bachelor of Engineering program underwent a major transformation. Remember, this is a major transformation. Any minor transformation at Hong Kong U is very, very difficult. So he made a major transformation in the curriculum. So we now emphasize a switch towards an interdisciplinary approach. Nowadays, we talk a lot about interdisciplinary approach, but Norman made a major shift to this approach a few years ago. He encouraged innovation and maker culture in student learning. He established the Research Student Center, which I believe is the only one in this region of the world. He put graduate students from different disciplines, forced them to sit together. The beauty is that he is actually making a very good environment for these students to exchange ideas, what we call brainstorming, and we are able to generate a lot of good ideas making use of this research student center platform. He also established the innovation wing, which will become our innovation and technology demonstration hub. His other major initiatives include the Advanced Robotics Laboratory, and recently he also took leadership on developing a major initiative in artificial intelligence and robotics, working together with Tohoku University. So we are most delighted that he is succeeding as the 8th Taikoo Professor of Engineering. His topic today is also a very interesting one. Artificial intelligence, is one of the most hottest topics today, and he will tell us more about AI from .yas to AI, a Hong Kong perspective. So may I now invite Professor Norman Tien to deliver his lecture. Norman, please.
All right. All right, got it. So thank you very much, Dean, for the kind introduction. And Merlin, thank you for coming and giving me a very high standard to try to keep in terms of trying to connect dockyards to AI. Right. So let me give a shot at it. So first, let's talk about Hong Kong, since in the title we're talking about a Hong Kong perspective in terms of in terms of dockyards to AI. So we all know that one of Hong Kong's great attributes is its geographical location. Right? You can see here how many, what percentage of the world's population is within, a short flight from Hong Kong. But over 100 years ago, Hong Kong's geographic location meant it had access to the resources in China, in the region. It had a wonderful port, so it was a wonderful asset. Now, if I talk about Hong Kong's development from, you can see here in the early 1900s to what you see today, a vibrant world-class city, I think there's one word that I think all of you would agree was a major factor in this, and this is commerce. Right? Hong Kong has been a tremendous center of commerce. Now, the acting president, Richard Wong, has left, so he's, of course, a very famous economist. And I'm glad he's not here because what I'm going to talk about may sound simplistic. After all, I'm only an engineer. But for me, commerce is trading goods. All right? So trading goods, that is, in fact, you might say, what really has been something that Swire has been very, very much involved in even before the 1900s, the trading of goods. And one of the things that Swire understood is that the trading of goods required technology. It needed technology because, well, one possibility is that you need the technology to create the physical goods. So here is an example of Taikoo sugar refinery. But I think more importantly is that word trade, right? Which is that you have to move those goods. And so as Merlin had mentioned, then Swire got involved in creating the Taikoo dockyards, first to support shipping from the engineering point of view, and then eventually to build ships, right? So in a sense, Swire had the foresight to be very heavily involved to bring engineering and technology into commerce in terms of developing Hong Kong. Now, this did not stop. So if we kind of fast forward, let's say into the 1950s, now the world is changing, right? Technology is also advancing. Transportation technology is advancing, and now we have air transport. Right? Air transport to go along with maritime shipping. And of course, Swire looked at this and said, well, there's Cathay Pacific, Taikoo in terms of aircraft engineering. So Swire has been very heavily involved in commerce, in the development of Hong Kong, on the transportation sector, making tremendous contributions, at least in the air sector. Now, Hong Kong, during this time, is also developing. So there's light manufacturing that's started up, whether that's garment, toys, you name it. These were new physical goods that were coming on board to be traded. People also, in terms of the service industry, in terms of just the knowledge and the expertise that they had in their brains, people needed to be transported, moved around. And of course, the start of financial services and other services here in Hong Kong. So this formula has been going on pretty well, right? Creation of goods, trading and transporting these goods to create value. Well, now we come to today, right? And today, things are changing rapidly. And in some sense, that traditional thinking of moving a physical good is now being replaced by a virtual world. A virtual world in which it's really information that's being traded. And the transportation is not necessarily physical. You need information flow, you need idea flow. Oh, you still have people, right, being, people flow in terms of their ideas. But in this now new world of, you might say, virtual goods, we still have services. You see the boom in fintech as a result of this. Smart goods. And smart goods may be something such as a software program, right? Or it could be drones that are being developed and sold. But you're talking about smart goods, you're talking about virtual goods. VR, AR is another example. And you're still talking about people and AI and robotics. So now we are in a different world, all right? And to some extent, it is a challenge for Hong Kong because it's not based on that harbor. It's not necessarily based on that central location that we used to have. So what are we going to do about that? Well, I think the first thing that we want to maybe take a look at is just what this playing field looks like today. Right? And we are in this era of digital transformation. And you can just see here some of the catchwords that have been out there, whether or not it is digital twin technology, we've mentioned AI, robotics, social media, big market, fintech, cryptocurrency, Internet of Things, e-commerce. I'm not going to name all of it. It's just to show you we have a really wide open, highly competitive, very diverse landscape right now. And very hard for us to be able to, put our hands around the whole thing, all right? So we have to pick our places, create our little niches here and there. Okay, so as we're going in and thinking about this, I think one of the things to help is just to understand, the root of what we are talking about, which is information. So what we are in is essentially in an information world. And this pyramid helps me understand, you might say, what is happening in terms of the value creation. And so, at least in terms of information, you can start with data, all right? Ones and zeros, a temperature measurement, a motion measurement. But it is just a simple number, all right? Or a simple piece of data or a simple measurement. How do you move from this data to something that has a little bit more value, some more information, right? Then if you can take that information and then gain some knowledge out of that, then it's going to become even more valuable. So yeah, maybe something simple in terms of an example would be a Fitbit, okay, what a lot of people are wearing these days, all right, in terms of on your wrist. And so there is some motion sensor in there that's just measuring some motion. That's just data, okay? But it's telling you that I took 10,000 steps, okay? So there was some processing that went on in there, some software that went on in there in order to tell me now some information, which is I took 10,000 steps today, okay? Now that 10,000 steps is of value to me, right? And this is why I would go out and buy a watch or a Fitbit, okay? Or now even more sophisticated, right? An Apple Watch will, the newest ones will measure your ECG, okay? So it's taking some data, processing into information saying this is your, well, older Apple Watch series is your heart rate, okay, in terms of beats per minute. But now you take that information, work on it some more, process it some more, you get your ECG, and then from there, you may be able to get some knowledge, okay? My pulse rate is too fast, okay? I need that knowledge. Oh, then I can maybe for my human brain say, let's say there was MSG waging at lunch, right? So now I'm, have a high heart rate, okay? This is information. And what we are seeing in today's world is that AI, all the developments in AI. Now, AI is maybe at this point an overused word. Has many, many elements underneath it, at least in terms of what I'm going to talk about today. It could be data analytics, what happens in the cloud. It could be machine learning. It can be deep learning. It can just be algorithms to help with pattern recognition. Okay, well, let's lump all of that into AI. It is this kind of software, computer science, algorithmic, machine learning development that is now being able to, we might say, extract even more information, even more knowledge, out of the data. Just give you an example of what AI can do. Recently I was a judge at a secondary school AI competition that Anthony, the WIN Foundation, was sponsoring, supporting. And these secondary school students had sensors, right? Which will, the goal of the competition was how to tell whether or not a strawberry is ripe, okay? So that's knowledge, all right? But how do you get, a ripe strawberry from raw data? That involves all that AI, all that processing, right? So there might be a sensor that measures the color. There might be another sensor that measures the size, right? But how do you get all of that to saying that it's a ripe strawberry? Okay, this is where, in a sense, AI has been playing a major role, right? And I have to say the secondary students in Hong Kong are excellent, right? And they've done a good job. But all of this creates value, okay? And actually, all of this information can be of value just by itself, okay? But if it results in some action, maybe a behavioral change, in terms of, my heart rate is high, I need to go do something about it, then there is some additional value that comes out of this. Or this could be, in a factory, right? So there's a machine that is, having some odd vibration, okay? And this requires some action, that's value. Or it's a robot, okay? Or it's a self-driving vehicle. I've got data, I'm gaining information, and it translates into an actual physical action, right? So now you can imagine, even as simple as the Apple Watch, right, giving me my heart rate information, I like that. I'm going to go out and buy a watch, all right? I'm going to go buy a Fitbit. And so what you see is just human nature, which is when there is something that is of value, I want more. Okay, so this is going to result in a very, very rapidly growing appetite, an insatiable appetite. Right? And already we're beginning to see this in the sense of an explosion of data. And in fact, you know, you're talking about now data being created with some odd words that, you know, I don't ever use, zettabytes or exabytes, right? Out here, by the way, a zettabyte is a trillion gigabytes, just to give you an example, all right? But to help you understand, if you take all the information that's been created throughout human history, you're talking about, you know, the scrolls back in biblical days to Greek philosophers writing whatever, to what's in the libraries, what is in old LP records, to everything that has been produced on CDs, right? And on and on and on. Oh, all the documentation in offices. Well, you know, some people basically say that the amount of data and information that's been created in the past year is equivalent, roughly, to all of that has been created in human history. So data is being generated at a huge explosive rate. And it's only going to get more. And here are, you know, here's transactional data, right? But here's the human files, the things that, you know, you produce in your office, for example, PDFs and Word documents. Social media, it's generating tremendous amount of data. Some of it's frivolous and some of it is of no use, but that's another lecture, okay? And then another area that's growing rapidly is machine-generated data. This is the Internet of Things. So this is something that is actually growing tremendously fast. So anyway, so we have an explosion of data. We have this real hunger, this real appetite for more and more. So then it means that we better take a look at then what are some of the elements, and in particular, the hardware elements that are supporting this creation, okay? So if I break down the hardware, there are computers, basically. There's data storage. These are the sensors. There's communications, okay? This is the hardware that's needed. And actually, the Internet of Things is a good example of showing that whole spectrum right there. You may have sensors out there, and at this point, we probably have at least billions of sensors out there, perhaps trillions. Many of them are communicating their information somewhere, likely to a central server, a central processor in the cloud, okay? So all of this is going through communications, needs to be processed and stored, okay? Now, the hardware today is actually not keeping up well with this explosion in data. And, whoops, hold on 1 second. Let me get here. And let me go to this slide first, which is the hardware is not keeping up. And so your data storage is not enough. Your processors are not capable of handling all that data that's going on. Communications, the bandwidth is limited. You know, this is actually one of the reasons why we're having such a controversy and conflict these days over 5G, right? Because of the value of communications, right? 5G is supposed to really open up the amount of data that you can send, right? The amount of data that you can send at higher rates. I tell you, 5G is not going to be even enough, okay? But it's a massive improvement, but it will quickly also reach its limits. So communication is a problem, latency, which is the speed, privacy and security, data storage, data processing. But just to go back one slide, which is on the data gathering. Besides being the Taikoo Professor of Engineering, I'm also Chair Professor of Microsystems Technology. So this is my home field. And so this has been an area that in the last 20 years has been in itself exploding. Just to give you an example, today in an Apple iPhone, this is a list of all the various microsensors that are in there. You have gyroscopes, barometers, accelerometers, of course, cameras, right? Now you'll have 3 cameras on an Apple iPhone. And one thing that I like to talk about, and by the way, this is a Knowles silicon microphone, but I don't think the Knowles is the same Knowles that we had just mentioned from Swire. But this is interesting because 20 years ago, when I started in terms of research in this field of microsystems technology, there did not exist a silicon microphone. And actually, it's one of the areas that I did some research in. Today, Knowles has sold billions of silicon microphones only within these last 20 years. And just giving you an example, this is about 0.7 millimeters in diameter, so they're small. And by the way, the Apple iPhone has 4 silicon microphones in there. So the multiplicative effect of all these devices that are being built to support this whole drive for information. But this is hidden, people don't see it, but it's growing rapidly. But more and more sensors will be developed because we want to be able to measure everything everywhere, right? So some guys at Harvard in the microrobotics lab are developing these robo-bees, okay? And so this is not a giant's fingertip, it's just a human fingertip, right? But you can see, though right now there's a tiny little wire that's powering it, they want to remove that, and so then you'll have essentially a little sensor that can fly around. Perhaps it will measure a temperature or measure a humidity. And you can have a swarm of these flying around, right? This is the future. And as you can imagine, a swarm of them, each one producing data that needs to be sent somewhere. Again, the information explosion is going to rapidly rise. It can be in different forms, right? Aircraft structure monitoring, right? Most of the aircraft these days are using more and more composite materials, right? Carbon fiber composites. You can wind fiber optics into these composite materials to measure, to monitor the structural health of an aircraft fuselage so that you don't have any mechanical failure, cracks, and things of this nature. So it's everywhere, all right? Now, it's everywhere. We have essentially a bottleneck. Usually when you have a bottleneck, you also have opportunities, right? So I'm going to talk about one opportunity. I'm not going to talk about data storage today, not going to talk about communications, but talk about microelectronics. And so right here you see, I've kind of crossed out Moore's Law. For some of you, you will know that Moore's Law was this thing that was coined by Gordon Moore, one of the founders of Intel. And basically what he said was that the number of transistors on a chip will double every 18 months. Okay? And actually, for the most part, it was just true. It was correct. So the industry followed Moore's Law. It just kept doubling the number of transistors on a chip every 18 months. Okay? But like anything, like many, many things in life, there is a lifetime. Though Swire seems to keep going after 3 centuries, which is very good, which is impressive. But for Moore's Law, more or less, we've had a 50-year run, all right, from, let's say, around the 1970s to today. Why? It's because finally we are reaching the physical limits, the limits of physics. Today, people in the industry are working on 5-nanometer technology, right? Which means on that chip, the minimum feature size, the smallest feature is about 5 nanometers. What's 5 nanometers? A silicon atom is about 0.2 nanometers. So basically, the minimum feature size is about 25 silicon atoms. You can't get much smaller than that, okay? So the industry, which is feeding this hunger, now has a problem, okay? So now we need something more than more. Okay, and it's a nice little catchphrase, and I'm borrowing it, in fact, because TSMC, which is the world's largest chip foundry out there, customers from Samsung, Apple, and everybody else, They actually now have a vice president who in his title includes more than Moore's technology. Okay. They have recently hired or brought on board a new vice president for corporate research as a Stanford professor, happens to be a Hong Kong U alumnus, Philip Wang. Why? Because they realize now they need to go beyond this traditional graph that they've been going on. Okay? They really need to be thinking of something new, something creative, something innovative. Now, this is an interesting graph because, for some of you, you may remember that roughly 20 years ago or so, Hong Kong thought about getting into the semiconductor chip business, all right, and it didn't happen. But about 20 years ago, which is to be something like around this point here, hard to see, if you look at this graph, we're about halfway into this run of Moore's law. So at that point, and if you look at the number of chips that have been developed then, actually the window was still open, okay, for Hong Kong to enter and then be a player into this. But if you look in the last 20 years or so, well, you look at all that, right? No. I mean, over the last 20 years, for Hong Kong to then, after having missed that point, to jump in would have been extremely difficult, right? Competition ramped up, technology ramped up. But we're now reaching the end, right? And now, it's become a little bit more of an open playing field. So it is actually become an opportunity for perhaps Hong Kong to take a look at jumping back into this. And in fact, this is going to become a major issue for the whole world because of the demand for new chips, right? So one of the things here, you can see, here, this is the traditional Intel microprocessor, which for Intel has been tremendous, okay? NVIDIA here, for those of you who have kids that like to play computer games, then they would understand an NVIDIA chip because that's the graphics processing unit, right? So NVIDIA produced these graphics processing units for supporting computer games, well, among other things, right? Well, it turns out that these chips, these NVIDIA chips, are very, very good at doing linear algebra, handling matrices. And then also now, independently, the computer scientists out there who are doing deep learning, there's a lot of linear algebra that goes on in terms of deep learning. So now, all of a sudden, NVIDIA produces chips that are excellent for AI deep learning development. New market for NVIDIA. But what it represents is that as this information explosion is rising, there's going to be more and more computational demands that may not necessarily be central processing, traditional microprocessors, may not be the most efficient and effective way of doing that. So this is part of the more than Moore's law activity, where there will be different specialized chips, there will be different new architectures, there will be new physical structures to the chips. It's an exciting time. It's an exciting time for everyone. Okay, so this is Moore's law, but I was talking about the fact that we're having this bottleneck, right, in terms of all this information going to central processors and central storage in the cloud. So one approach is, of course, to do better processors, which I talked about in terms of Moore's law. The other approach is to relax, right, the amount of transmission that's going into the cloud, so to speak, right? And this is why some people now call edge computing. In other words, doing computing, doing your AI, doing your storage at a local level, all right? Yes, the processors may not be as powerful, the storage may not be as good, it could be a, quote, smaller AI component that's there, but it will relieve, you might say, that pressure on the overall central system. Also, there are certainly applications in which you need to be more on the local level. Here's an example. Image data, let's say this is a self-driving car, autonomous vehicle. So you have some image coming in. I'm going down the road and I see a lamppost in front of me or a tree in front of me, okay? If I need that to get that image uploaded to the cloud, process it there, then send it back to take some action, in other words, avoid that lamppost, all right? The time it took, it's red, maybe too late, I'm already in that lamppost, okay? So yes, what does edge computing mean? It means that I take that image, I process that data right there in the car, right? And I take immediate action. Just one example, right? The Apple Watch is actually also edge computing, right? It's doing a lot of processing right there on your wrist, right? So it's not all critical systems, but it's, also things down there. Here's another example. It's, I think, a cute device that some students at Carnegie Mellon University put together, and you can see from the photo, it's just a small sensor, it's a measurement unit, but they've got a list of about 9 different sensors: cameras, microphones, accelerometers, pressure sensors, humidity sensors, temperature sensors on there, and they put it into the kitchen, okay? And it's got AI on here too, microprocessor, storage, it's got a little bit of machine learning, and so it's just listening or monitoring all the time. And all of a sudden, because there's some microprocessor, there's a little AI there, you can't see this very well, but then all of a sudden it'll say, oh, the water faucet is running, okay? Oh, here, the water kettle started boiling, it finished boiling, the microwave door opened, it closed, right? So this is taking all those little data, providing some information because of some processing, and then getting some knowledge out of that. And then one can do something with that knowledge. So just give me an example of, I'd say edge computing. Why I bring up edge computing? Because I think in terms of edge computing is a wonderful opportunity in terms of smart goods, right? As I talked about at the very beginning, for this new world of commerce, smart goods. Smart goods could be related to autonomous vehicles. It could be just some software system, watches a digital twin of whether or not it's an aircraft, a building, a city, a hospital, robotics, VR goggles, you name it. There are many, many smart goods out there. Today, I'm not going to go into saying what should be done or shouldn't be done. This is up to you guys, right, to think about what might be possible. So, of course, we started talking about Hong Kong, right? And so, Hong Kong right now these days there's a lot of effort in terms of innovation and technology. Some of you in the very, very back out there, like George or Nick, may not be able to see. So I'll mention some of this. So I found this from a government website, one of the Hong Kong government websites. To ensure long-term economic stability and growth, Hong Kong must create new and more effective niches through innovation and technology, okay? Innovation and technology are important to all sectors of the economy, including traditional industries, as well as service industries. They may be applicable to every aspect of the value-adding chain. We envision Hong Kong to be an innovation-led, technology-intensive economy in the 21st century, serving the region as a center for development and commercialization of innovative ideas and technology, in addition to Hong Kong's current role in the business and financial center, okay? So on the government website, I said, wow, this is perfect. I need to show this. Now, what is, you might say, funny about this is that actually my dad spoke those words back in October of 1998. Okay, and so you might say, we need to do more. At that time, as you can see, this was at a press conference for the release of the first report for, at that time, the Chief Executive's Commission on Innovation and Technology. Okay, so we do fast forward to today. Okay, so already in the blueprint for the Greater Bay Area, it has been identified that Hong Kong be an international innovation hub. You might say the international innovation hub to support the Greater Bay Area. And so, of course, yeah, we here at Hong Kong U, we thought we better start working on this, right? And you know, we're good engineers. We look at the problem here and we say, well, Japan is certainly a world leader in technology. Nobody will question that. Japan has also been a world leader in robotics and AI. No one will question that. So can we bring Japan to Hong Kong? Okay, in terms of collaborative efforts on innovation and technology, particularly in this area. And then from Hong Kong, let's take a look at some of our attributes, right? And one of the attributes is Hong Kong is a mega city. Maybe not necessarily in terms of the actual population, there are much bigger cities out there, but in terms of the density in Hong Kong. So it actually makes Hong Kong a perfect test bed for a lot of things that, you know, we would do for mega cities. And actually, I think, you know, if I pull this back to a commerce, you know, theme, then the idea is develop things for mega cities. We're a perfect test bed for the development, and then outsource it to the rest of the world. Well, to some extent, it's like what MTR is doing in terms of, you know, building train systems elsewhere. So we here at Hong Kong U then have teamed up with Tohoku University in Japan to form a collaboration. So one of the first things in terms of the collaboration is in the AI and robotics area. And so we are working to put together a center for transformative AI and robotics technology. So this kind of TransArt Center, let's use a coin of phrase, has two, you know, umbrella themes, all right? One is to address megacity applications. The other one is to look at next generation of manufacturing. And of course, within here, there are some specific projects. We call them pillar projects. Future industrial robots, robotics for garment manufacturing, AI and robotics for megacity infrastructure, collaborative robots, meaning robots working with and together with humans. And then robotics for disaster response within megacities. So these, of course, are, you might say, the target, you know, application and the target development. But in order to realize these, we need some underlying platform, you might call it technologies, underpinning technologies, whether or not it's modeling, system integration, sensing systems, planning, navigation, cyber-physical systems. These are things that we need in terms of underpinning technologies. And as it turns out, Tohoku University is very good at the robots and the development of robots and the research into robots. Hong Kong U is actually very strong. Though we have robotics, we also are extremely strong in these underpinning technologies. So this collaboration is, in fact, quite synergistic. The outcome should be much bigger than what each of us are able to do. So next few slides, I'm running out of time. I'll just give you a snapshot of some of the technologies that Tohoku and Hong Kong are bringing to the table rather than talking about what we will be doing into the future. But giving some examples, Professor Kosugi, who's essentially the co-PI for this particular project, has been doing a lot in terms of collaborative robots and future industrial robots. One very challenging problem for robotics is actual two-arm manipulation of something. If you look at a General Motors, Toyota automobile plant, it's one arm, because one arm is easy, okay? Two arms is actually not that easy, okay? Just in terms of even manipulating this laser pointer here with two arms is not easy, okay? So Professor Kosuge, who is actually here in the audience, has been working on dual arm manipulation systems, something that will be very needed as we move to more advanced manufacturing, where we want the robotic system to be more flexible, being able to have higher functionality. This, of course, has been fun for him, doing dance partner robots, either a dance partner or a dance teacher, okay? But you can imagine that this is a challenge, because if that robot steps on your foot, okay, it could hurt a lot, right? So, so this is something that, you know, is a good vehicle, but you can't see this photo too well. It's a bit dark in the image, but the real industrial application, of course, is having a robotic system working with the person here in terms of being able to provide, bring tools. It's kind of like in a operating room in a hospital where somebody's handing the doctor scalpels and clamps and things of this nature, right? Just go through real quick. We've got people who are working, for example, Wenping Wang, who is working on vision systems, Japan, motion planning, how you actually plan the motion of these robots, Gawai doing manipulation of robots in medical systems, VR, AR systems by Henry Lau, and Internet of Things by George Huang. And then for disaster response and megacity infrastructure, we are actually fortunate to have Satoshi Tadakoro from Tohoku University be involved. He is well known in Japan because after the Fukushima Daiichi nuclear power plant disaster, in which robots failed, right, in trying to, in going in afterwards in terms of disaster response, that the Japanese cabinet directly funded his research in trying to develop new robotic systems. One that's come out is Quince for search and rescue. He's also been working on firefighting robots. There was some news media press recently on this here in Hong Kong as part of what we plan to do for the new center. Everything from here a gripper that operates under harsh environments, high temperatures, to different forms of firefighting. This is something that we actually at Hong Kong U have a lot of effort in, which is in looking at infrastructure and infrastructure modeling and prediction. So this is where you take AI, essentially, and sensors. You look at crowdsourcing, sensing the crowds, okay, and looking at crowd patterns, for example, to help you determine building maintenance, asset planning, okay? One of the things that we want to do, for example, in terms of disaster response, would be look at evacuation planning or routing under, let's say, you know, certain incidents that may happen. Let's say MTR breakdown, right? Then how do you route traffic within the city? Foot traffic, road traffic, bus traffic, as an example, right? And this is applications where AI can come into being. All right, so let me wrap up a little bit here. We are, without a doubt, in this era of digital transformation. And in this era of digital transformation, first, tremendous growth in wealth. I'm talking about in terms of global wealth, the GDP, right? Because economic opportunities. And because there are great economic opportunities, there is no way that the technology will not advance. And there's no way that the technology will not advance rapidly. But this rapid advancement of the technology will mean, well, there could be workforce changes. There will be societal changes and lifestyle changes. Don't have time to get into all of this, but there is also ethics issues that will come up. Social media is a very simple, easy to understand example. Fake news, is it fact or fiction? That has tremendous impact on our society. And there are a lot of ethics issues involved. Or it could be even something as straightforward as a critical system as what's happened with the 737 MAX, in which the AI system was likely a factor in the two accidents in Indonesia and in Ethiopia. So we are entering a world in which there is a lot of change, and in fact, policy and laws are not keeping up. Just like the hardware is not keeping up with the data explosion, our policies and our laws are not keeping up with the technology advancements. So something for all to be aware of, that these things have to come along. Now, oftentimes when I'm at a university, people are always asking me, yes, with all this workforce change that's imminent, what should I do? Okay. And it is a changing job landscape, and it's serious, right? I mean, self-driving vehicles, you can already see that drivers, that occupation will go away, right? It will only be people who want to drive it as a hobby, right, that you will actually go out to learn to drive. But I think, where the biggest change, and maybe hard to stomach, actually will be in the professional services, right? Many of the people who are working in the legal profession, they just extract, old cases. They do research, combing, for information, and then doing some, analysis. That will be replaced by AI. The medical profession, right? I see Rosie here. Thinking about the medical profession, if you look at, you take a radiologist, right? And they're looking at an X-ray and looking for bone breaks. Yes, I think an AI system will someday be able to do that just as well as a doctor. I tell, even when I'm out in the faculty, that for some professors, their job will change too. Okay? Some of the teaching, or at least some of the ways that some of our professors teach, can be replaced by online kinds of, tools, right? But the research will also change. There are professors, let's say in material science, where it's been trial and error, okay? I try a new material, I make the measurements. Yeah, that can be actually systematically replaced by AI and robotics. There have been a lot of professors who do tremendous amount of numerical modeling and numerical simulation, numerical developments. Well, some of that stuff may also change, okay? So even for professors, okay, actually going into the future, there are two things that really people need to try to nurture, grow, and enhance. That is creativity and innovation. Okay? This is in fact something that, at least in the near term, AI systems may not be able to do that well. Okay? So whether or not, again, whether or not you're a professor, whether or not you're a manager, and you have to manage people who are going to be, more focused on creativity and innovation. Whether or not you're there are some students here, green gown, with their green gowns on. I would encourage, over the years, whatever years you have remaining here at Hong Kong U, and then beyond, to hone that creativity, that innovation, because those are going to be the things of value to society that at the moment AI and robotics are not going to be able to do. And there's a beauty to creativity and innovation. And creativity is that you can't use it up, right? This is a quote from Maya Angelou, who is was a famous American writer and poet. You can't use up creativity. The more you use, the more you have. So thank you very much.
Thank you, Professor Tian, for a very inspiring lecture on the future of robotics and AI. May I once again thank all of you for joining us at HKU. Good night.